All right, now let's actually do some work with significant figures. We'll look at the rules, and then we'll give you some examples, and we'll just go through it and see what progress we can make. So here we have a list of rules that helps us determine how many or what our significant figures are. So the very first one is the simplest. It says non-zero numbers are always significant. So if I'm going to go down here and look at some of my practices, I'm going to look for non-zero numbers. Well, that 1's a non-zero, that 2 is a non-zero, and that 5. So I know that in that number right there, I at least have 3 significant figures. My second rule, though, leading zeros are never significant. So, for example, if I have a leading zero, this zero here on the left side of the decimal and that, those are called leading zeros. Neither of them are going to be significant. And here I have a bunch of leading zeros. This one, that one, that one, and that one. None of them are going to be significant. So, in this number here, the only 2 significant figures are those that are non-zeros. Those 2 are, and then, well, these are trailing zeros, so they're actually going to end up being significant. But we know that these 2, because they are not leading zeros and they are non-zero, at least they are. And we'll talk about why those last 2 are also significant. That number is actually going to have 4 significant figures. The next one is going to be embedded zeros. They are always significant. So this is a 0, and we might say that sometimes zeros are not significant. But if it's embedded in between 2 non-zeros, like that 2 and the 5, always going to be significant. Those 2 zeros right there, they're embedded in between the 3 and the 8. They're going to be significant. Okay, so let's find an embedded 0 here. That 0 right there in our first example, that one's embedded. So that one is going to be. So if I would look at this, I know that that's at least going to have 4 significant figures. Our only question about this number is whether that last one is significant. And let's deal with that now. Trailing zeros are significant only if the decimal place are specified. You have to actually see the decimal place, like that one right there in the example, or in the practice problem. Or like this one here in that example. Because I see that decimal place, then I know that those last 2 zeros, they're significant. Here, there is no decimal place there. So for our class, we are going to say that we honestly don't know whether those are significant just by looking at them, but the rule of thumb we're going to follow is that any number that doesn't specify with a decimal place, we're going to say that this number only has 3 significant figures. And the last one is zeros at the end of a number without a decimal point. That's what this is here. They're ambiguous and they should be avoided. And the great way to get around those is to use scientific notation. And you'll find that every scientific notation example that we give you, it automatically tells you the number of significant figures. You can look at that scientific notation and you can tell that there are 3 numbers and there are 3 significant numbers in that. And that's going to be the case. Here, it's the same number of significant figures because there is no decimal point here and they're on the trailing end, so those aren't going to count. All right, so now we're going to come back to determine some practice. Okay, so our only questions about significant figures are going to be the zeros. We know that that 1, that 2, and that 3 have to be significant because they just always are. We determined this one was significant because it's an embedded 0. And we're going to call this one significant because I have a decimal point and it is a trailing 0, just like these right there. So in this case, I have 5 significant figures. This number here, 32500, that's really similar to that one, of course. We're going to say that this only has 3 significant figures because I don't have a decimal place defining the accuracy. Here I have leading zeros. Okay, I don't have a 1 or a 2 on this side of the decimal point, so these are just leading zeros, and they're never significant. So this one is only going to have 2 significant figures. Now we're to scientific notation, and we're going to love that. Anytime you have it written in scientific notation, all you have to do is count what you see, and you're going to call that significant. So this is going to have 3 significant figures. Here we have trailing zeros and a decimal point, so they are also going to be significant. So this is 25.00, and every one of those numbers are significant. Okay, so the next thing to do, once we know what is significant and what is not, now we have to talk about rounding off numbers to the correct number of significant figures. So, you've already probably dealt with rounding numbers in math in the past. Let me give you the rules that we're going to follow in chemistry. They're actually no doubt the same ones that you've already encountered in algebra. If you're rounding number to the correct number of significant figures, if the number following the last significant figure, if that is 0 to 4, then you just leave that number unchanged. You leave it the way it is. That means you drop all digits after the last significant figure, and you in effect round down. Okay, so this number 7.248. If we were going to record it to two significant figures, that would be 7 and 2. The number following is a 4, and it would have to be a 5 to come into play to round up. So we're going to report this as 7.2 to two significant figures. Here you can add insignificant zeros to keep the value. So here we have 7,248. If we are going to report that to two significant figures, obviously we can't just say 72 because that would look like 72. So we add what we call insignificant zeros. So we would write this as 7200. That's what we would put there. And that, in effect, rounds this number down to a number that's within significant figures. And then the other side of it is sometimes we round up. If I have a digit that's 5 to 9, so that's the larger side, we're going to drop all digits after the last significant figure, and we're going to increase the last one by 1. So if I am going to report this number, 7.258, to two significant figures, well, it's going to have to be 7.2, and 5 is greater than 4, so it doesn't fall into that. It falls into the 5 to 9 category. Then I'm going to round this up to 7.3. That would be this number reported to two significant figures. And we are allowed to add insignificant zeros to keep the value as well. So here we have that similar number, this one up here, but this is 7,258. If we're going to report that to two significant figures, we're not just going to say this is 73, because we're going to round that 2 up to a 3. We also have to add some insignificant zeros, so this would be 7300. That's how we would report that. And it's really helpful if you want to avoid accumulating extra error from rounding, and you're going to be rounding an awful lot. It's not a bad practice. Actually, the practice that we're going to adopt in this class is that you do all of your math, and then at the very last, your final number, you round up or down just one time, so that you're not rounding up and down all throughout the path that we get to the end. So that's significant figures, and that's rounding off significant figures.